The universe may have built monsters before it built normal galaxies. That should sound wrong, because according to the story we trusted, it is wrong. Galaxies were supposed to come first. Gas gathers, stars ignite, gravity does its slow work. Then, after enough time, black holes grow into monsters. That was the safe version. Then James Webb looked back toward the beginning of time and found tiny red points of light, small, faint, almost harmless. Astronomers gave them a quiet name: little red dots. It sounds innocent. It is not, because these dots are not nearby stars. They are not random telescope noise. Some of their light has traveled more than 12 billion years to reach us. That means Webb is not just looking across space. It is looking backward in time, into an age when the universe was still young. Too young, maybe, for what we are seeing. At first, scientists hoped the answer was simple. Maybe it was dust. Maybe it was distance. Maybe it was stretched light from young galaxies. That was the safe answer. Crisis averted. The universe still made sense. Then the data refused to cooperate. Some of these little red dots may not be ordinary galaxies at all. They may be hiding, growing black holes, buried inside dense gas, feeding behind a red curtain. And that is where the problem becomes darker. Because the terrifying part is not that black holes exist. We already knew that. The terrifying part is timing. If these red dots are hiding black holes, then the universe may have built its first monsters earlier than our models expected, maybe much earlier. So this video is not just about red dots. It is about whether the early universe was hiding black holes in plain sight. By the end, you will understand why these tiny objects became one of the biggest mysteries of the James Webb era. Why the safe explanation started to fail. Why one X-ray clue changed the suspect list. And why something so small in Webb's image may be pointing to one of the biggest problems in modern astronomy. Because sometimes the universe does not hide its monsters in darkness. Sometimes it hides them in light. To understand why these dots matter, we have to understand what Webb actually saw. Not a close-up, not a shape, not a normal photograph, just light, old light, stretched light. Light that crossed most of cosmic history before it touched Webb's mirror. When we look at a little red dot, we are not seeing something nearby. We are seeing something ancient. Some of these objects sit about 12 billion light years away, or farther. That means their light began traveling long before the sun existed, before Earth existed, before the solar system had formed, and in that early darkness. Webb found dots, not giant spirals, not familiar galaxies. Dots, compact, bright, red, strangely simple. That was the first problem. Because simple things in the early universe should not carry this much weight. Astronomers tried the safest explanation. Maybe they were young galaxies, small, dense, packed with stars. Maybe dust made them red. Maybe distance stretched the light. Maybe Webb had only found an unusual population of early galaxies. That would have been strange, but acceptable. The universe still had a place to put them. Then the numbers started fighting back. Some objects looked too compact, too bright, too dense, as if too much mass had been squeezed into too little space. If they were galaxies, they were strange galaxies. If they were star clusters, they were extreme ones. And if they were black holes, then the problem became much worse. Because black holes need time, they need gas, they need feeding, they need growth, and the early universe was not supposed to give them enough time to become this important so quickly. That is where the fear begins. Not with size, with timing. A giant black hole today is not surprising. The universe is old now. It has had billions of years to build terrible things. But a growing black hole near the beginning of time is different. That means the universe learned how to build engines early, maybe before galaxies had finished becoming galaxies. Little red dots became more than a category. They became a warning. Red light can mean dust. It can mean distance. It can mean old stars, or it can mean something buried, something hidden behind gas, something feeding so deeply that the usual signals cannot escape. From here on, the color is not the answer. The color is the curtain. Many scientists now think some little red dots may be supermassive black holes, embedded inside dense clouds of gas. That gas acts like a wall. It hides the engine. It blocks the usual signals. It makes something violent look almost quiet. A monster with the lights off. That is why the name feels wrong. Little red dots. It sounds small, almost harmless. But in astronomy, small in an image. Small in an image does not mean small in reality. It only means far away. Webb gave us the suspects, but it did not give us the confession. Because Webb mostly reads infrared light, it can reveal ancient objects hidden behind dust and distance. But a feeding black hole often gives itself away in another language. X-rays. That is where Chandra enters the story. Chandra does not look for the same clue. It looks for violence. When gas falls toward a black hole, it heats up, it accelerates, it becomes extreme, and sometimes it releases X-rays. Not soft light, not harmless glow. X-rays, the kind of signal that says matter is being crushed by gravity. For years, that was the problem. If little red dots were hiding black holes, where were the X-rays? Why were they so quiet? Why did the monsters not roar? Then scientists found one object, one out of hundreds, and it changed everything. It looked like the others, small, red, distant, almost forgettable. Its official name is 3JWST-Aegis-12014, but the name is not the important part. The X-rays are. This object sits about 11.8 billion light-years away. That means its light began traveling before the sun existed, before Earth existed, before anything in our solar system had formed. It looked like a little red dot, but it did one thing most of them did not. It glowed in X-rays. That does not prove every little red dot hides a black hole. It does not solve the entire case, but it proves the harmless explanation is no longer safe. At least one object with little red dot features can also carry the X-ray signature of something more violent, a bridge between the hidden objects Webb found and the growing black holes we already know how to recognize. That is why this one dot matters. Not because its name is memorable. It is not. Not because it is the biggest, not because it is the brightest, but because it may be the missing link, the first crack in the red curtain. And once that curtain has a crack, we have to ask, what else is behind it? The terrifying part is not that black holes exist. We already knew that. The terrifying part is that they may have started early, too early. In the nearby universe, supermassive black holes sit inside the centers of galaxies. They are huge, millions or billions of times the mass of the sun. But that size usually comes with time. Galaxies merge, gas falls inward, stars die, matter feeds the center, the black hole grows, slowly, violently, repeatedly, over billions of years. That is the version that makes sense. But Webb keeps looking backward and finding objects that seem too mature, too organized, too massive, too soon. Little red dots fit into that problem. They may not be the only problem, but they are one of the strangest. Because they look like tiny red points, yet they may contain the engines that help explain how the first giant black holes formed. How do you build a supermassive black hole when the universe is still young? One answer is slow growth. Small black holes form from dead stars. They merge, they feed, they grow. But that takes time, too much time, if the early universe already contains giants. Another answer is more violent. A massive gas cloud collapses directly, not into a star first, not into a normal object, but into a heavy black hole seed, a shortcut, a monster seed. If little red dots are connected to that process, then we may not be looking at the normal baby galaxies. We may be looking at a hidden stage, a phase where black holes are being born or fed inside clouds of gas. The universe may have had a faster path to darkness. That is what makes these dots feel dangerous. They are not dangerous to us. They are too far away, too old, too distant in time. Their light left before Earth existed. But they are dangerous to our assumptions, because they suggest the early universe may have been better at making black holes than we thought. And that changes the order of the story. We usually imagine galaxies first. Stars gather, gas settles, a galaxy forms, then the black hole grows at the center. But what if that order is not always right? What if, in some places, the engine came early? What if black holes helped shape the first galaxies from the inside? What if the monster was not the ending? What if it was part of the beginning? That is the uncomfortable possibility. Little red dots sit right inside it. They also do not behave like normal quasars. A quasar is what happens when a supermassive black hole feeds openly. Gas falls in. Radiation explodes outward. The galaxy center becomes bright enough to be seen across the universe. Quasars are cosmic beacons. They announce themselves. Little red dots do not announce themselves that way. They are quiet, compact, hard to classify. If they contain black holes, then those black holes are not fully exposed. Not alive, not dead, something in between, something buried. Not a normal star, not an exposed black hole, a hidden engine wrapped inside a glowing atmosphere. That phrase sounds strange. It should, because the object is strange. It may be a transition, a moment when the black hole is still buried, but beginning to reveal itself. That is why the X-ray dot matters. It may be the stage where the disguise begins to fail. A dot that still looks small, still looks distant, still belongs to the mystery. But now, something violent leaks out, as if the curtain has become thin in one place, as if the engine inside has found a crack. Webb sees the curtain. Chandra sees the energy leaking through. Together, they may be showing us an object. At the moment, its disguise begins to break. Not a full confession, a clue, but in astronomy, one clue can change the target list. One signal can change the model. One dot can change the question. Now the question is no longer, are little red dots weird? The question is, how many are hiding engines? How many are baby galaxies? How many are buried black holes? How many are something we have not named yet? That uncertainty is not weakness. It is the reason this discovery matters. Science does not move forward when everything is clear. It moves forward when something refuses to fit. Little red dots refuse to fit. If they are galaxies, they are too compact. If they are stars, they are too extreme. If they are black holes, they are too hidden. Every explanation carries a problem, and that is how we know. We have found something important. The universe is not obligated to match the categories we built. We built those categories from what we had already seen. Then Webb looked deeper, and the categories started to bend. That has happened before. We thought the universe was static. It was expanding. We thought black holes were mathematical ghosts. They became objects we could image. Again and again, the universe has shown us that our mistake was not curiosity. Our mistake was confidence. Little red dots may be one more reminder. They are small in the image, but they may be large in meaning. They may explain how black holes grow. They may explain how galaxies form. They may explain why the early universe looks more mature than it should. Or they may force us to invent a new category entirely. That is why astronomers are not done with them. Webb will keep looking. Chandra has already changed the story. Future X-ray observations may search for more dots that leak high-energy light. Spectroscopy will test their gas. Infrared data will test their stars. Models will test whether the glow belongs to dust, gas, stars, or buried black holes. But the biggest question will remain. What are we really seeing? A young galaxy, a black hole cocoon, a first engine, or a phase of the universe? We were never supposed to miss, but did. That is the beauty of this mystery. It starts with something almost invisible. A dot, a red point in deep space, something a viewer could scroll past, something a non-astronomer might ignore. But inside that dot, there may be a question large enough to reshape the history of the universe. How early did the first black holes grow? How fast did they feed? Did they grow inside galaxies, or did galaxies grow around them? And if the universe could hide that answer inside tiny red light, what else are we misunderstanding? Because it looks too small to matter. By now the name should sound different. Little red dots. Not harmless, not simple, not decorative points in a deep field image. Suspects. Some may be galaxies, some may be starbursts, some may be black holes, and some may be the missing stage between the first dark seeds and the giant engines that later ruled the centers of galaxies. That is why the fear angle is not fake. It is not about danger to Earth. It is about something deeper. The fear that the universe grew complexity faster than we expected. The fear that our timeline is incomplete. The fear that the monsters were not late arrivals. Maybe they were there near the beginning, small in our images, hidden in gas, wrapped too deeply to see. James Webb found the dots. Chandra found the warning sign. Now astronomers have to decide whether they are looking at baby galaxies or the first hidden monsters of the universe. And that may be the real discovery. Not that Webb found red dots, but that the earliest universe may have been far less innocent than we wanted it to be. We began with a wrong assumption, that the universe built galaxies first and monsters later. But little red dots may be the clue, that the order was never that simple. Maybe the universe did not wait. Maybe the monsters came first.